Okay, we're going to be working on adding and subtracting polynomials. Well, the first question becomes, what the heck is a polynomial? Okay, if you look, let me turn the page. First off, a monomial is just one term. It's something like when we just have the number 3, or if it's just like an x, or x squared. Mono means one, so that's when there's one term. A polynomial, if you think about it, the prefix poly, what does poly mean? We should know it means many. So poly is like when there's many terms. There's lots of them. It's the sum of monomials. Remember, sum means addition. So a polynomial is going to be when there's lots of monomials, lots of one terms added all up together. Two different types have special names. Binomial, that prefix means 2. So this is when there is 2 terms. So for example, we'll have like x plus 3, or maybe it's x squared minus 4. It's when there's just 2 terms and that's it. Now trinomial, we should know that the prefix tri means 3. So this is going to be 3 terms. So an example of like what we're going to see for a trinomial is like x squared plus 5x plus 6. That would be a common trinomial that we'll see. And no, there's no quadnomials and septomials or whatever. Okay, I'm totally making up those last 2, okay? But there's not, the only ones that have special names are monomial, binomial, and trinomial. Anything over 3 terms we call a polynomial, just meaning that there's many of them. Okay, so like right here it says, use algebra tiles to model each polynomial. Combine like terms and write the resulting polynomial. So what it's telling us to do is this. First off, this monomial right there, that says 2x squared. Remember in algebra tiles, x squareds are the large x's. I don't even think we've gone over that, have we? Okay, let me go back over here a second. And I think there might be room on the back. What we have done is this. We have the rectangles, which are x's, right? And the colored in ones is negative x. We had the ones, the units, and this one would be a negative 1. The only other thing we had was like the longer rectangles, wasn't it? What did we use for those? Don't everyone jump at once. That was a y. When we had the longer rectangles, those were y's. Nice drawings. I know I'm a super good artist. So now what we're going to have, and we'll see why later in probably with what we're doing tomorrow. When you have we're going to have a large square like this. This is going to be an x squared. Okay? And there's a reason for that, and we will see that when we start multiplying tomorrow. Okay? And then if it's colored in, that's a negative x squared. Okay? So that's the only difference. That's the only new tile that we're going to be adding this year for the rest of the year. All right, so going back here, it says 2x squareds. So let me go ahead and draw those algebra tiles. I've got 2x squareds. Then the next term says 3x's. So I'm going to make 3x. And the next one says plus 2. Okay? So now from here, I'm going to look, this says plus, so I'm adding all this stuff over here in this parentheses. It has 1x squared. Then it says minus 5x. So let's draw 5 of those negative ones. And minus 5. So those are the units. Okay, so all I've done is represented what was in the numbers and letters. I represented them in tiles. So now what we want to do is we want to combine like terms and put together the things that are alike. Well, the big squares, the x squareds. I have 1, 2, 3. Oh, I didn't mean to write 3. There we go. I have 3x squared. Well, if I look at it up there with just the numbers, 2x squared and 1x squared, that's where my 3x squared comes from. Down here for my x's. Now I've got 3 positives and 5 negatives. A positive takes away a negative. Positive takes away a negative. Positive takes away a negative. Well, what am I left with? These two right here. Yeah, I've got 2 negative x's. So minus 2x. Well, that makes sense because I've got 3x minus 5x. Well, what's 3 minus 5? Negative 2. So then the last bit I have, where'd it go? There we go. I've got 2 positive units and 5 negatives. A positive unit takes away a negative unit. Positive takes away a negative. What am I left with? 3 negatives. Which totally makes sense because, again, 2 minus 5 is negative 3. Now, I want to remind you, because we've done this before, just not with the x squareds, but if we wanted to check this to make sure that we were right, remember that you would take, let me erase all those circles here. You would take the original problem and put it into y1. You would take what you believe the answer is and put it into y2. Then when you press second graph, how do you know if you're right? What does it look like in your table? All the numbers in y1 should equal y2. They should look exactly the same. So if we go here, let me pull up my handy dandy calculator. Where'd it go? There we go. Do you have to put the parentheses? When it's addition, no, but we're going to have a subtraction, so just get in the habit of using the parentheses, yes. That way it won't mess you up when it changes a little bit. Okie dokie, let's see here. So I'm going to clear my memory because I had all that quadratic stuff in there. I'm going to go to y equals. I'm going to put in there 2. Oh, I was going to put the parentheses. All right. 2x squared plus 3x plus 2. Close those parentheses. Put another plus. Then we've got x squared minus 5x minus 5. And I think the answer is we have down there 3x squared minus 2x minus 3. Okay, so when you press second graph, these two columns, the y1 and the y2 columns, should be the same. See how it says the 3's are the same, the negative 3's, the 2's, the 5's, the 18, they look exactly the same. So when you do that, that means that you know that you got it correct. Okay, so let's look at number 2. Now, what do you notice? What's the difference between number 2 and number 1? There's a subtraction. Okay, that's going to make a difference in what we do. And what it tells us is it says take the opposite of all the terms in the second polynomial, then combine like terms. Okay, so what we're going to do first, you're going to do this just like we did the first part right here. Let's go ahead and let's make 2x squareds. And then plus x minus 4. So I have 4 negatives right here. Now it says take the opposite of all the terms in the second polynomial. What do we know about that parenthesis right here, right outside this parenthesis? What is this? It's a negative, which is the same as a negative 1. if I distributed and I multiplied by -1 by everything, that's why we're doing it. We're changing the sign. Because -1 times a positive x is negative, or by a negative x squared is a negative x squared. -1 times 4x is positive 4x. -1 times positive 1 is -1. That's why it's telling us to change the sign of everything in the parentheses behind it. So now when I go down here, I'm going to have a negative x squared, a positive 4x, and a -1. That's the only thing different than what we just did. So now we can go through and we can combine our like terms. So to find our answer, a positive x squared takes away a negative x squared. So how many x squareds do I have now? I have 1. So I have x squared. What about my x's? Do any of them cancel? I've got 1, positive, 2, 3, 4, 5 x's. Plus 5x. My units, I've got 4 negatives and 1 negative. There's no zero pairs, so all I have is -5. And again, to check it, you put in y1 and y2. I promise that on your tests and quizzes, you want to make sure you take the time to check because you don't want to make a small mistake when you know how you can go through and check it on the calculator. Okay, now this one, it's not written side to side, but it's straight up and down. We could kind of treat it just like we would an addition problem. What they've done is they've lined up the terms that go together. See, this is saying x squared, y squared, x squared, y squared. So I've got 4 of these, and I'm adding 6 of them. So how many total do I have? 10. So it will be 10 x squared, y squared. Okay, wait. Okay, so here's the deal. Let me go back. When we were adding x squared plus x squared, how many did we get? We got 2x squared, right? We didn't do anything to those exponents. This is just saying that that tells me that these things go together. And we made them, because we made them into like big squares, right? Well, there's no special symbol for x squared, y squared. That'd be like saying that I have 4. If I made a symbol for x squared, y squared, there's my x squared, y squared. That's a symbol. Okay, I'm totally making that symbol up, but that'd be the same as saying I have 4 of these, and then I add it to 6 of them. How many do I have? And that's where the 10 is coming from. The x squared, y squared is just saying that those two things go together. Okay, we're not doing anything else with the exponents. It's just telling me that those are special and they go together as a click. So then we have xy and xy, so I know these go together. So all I'm going to do is add, what is 5 plus 8? So plus 13 xy. Now my xy squared, I have xy squared down here. So all I'm doing is looking at the coefficients. What's -3 plus 3? 0, so it goes away. This is my answer. Now the thing on this would be, what do I do to put in the calculator? Yeah, this one sucks. You can't put them in the calculator. I don't know. Can I say that on a video? This one stinks. You can't put it in the calculator. Okay. Filter. I guess there's none of that, right? This is kind of like live TV. All right. So you put these together, but we can't check them because of the y's. We can't put those in the calculator. So this down here, what's the difference in number 4? We're subtracting. And even though they're on top of each other, see what's going to happen is you have to change the sign of all of this down here. So this is a positive 5m squared. This would be negative. What would the 6m change to? Positive. What about the 17? 17 would change to negative. So now that I changed them, now we can go through and put them together. What is 11 minus 5? 6m squared. Now look at these numbers. 2 plus 6, 8m. Negative 11 minus 17, negative 28. Okay? You could check this, but what would you have to change the m's to? You'd have to change them not to x, but to, oh, I lied. Yeah, to x. Thank you. Woo. Okay, yes, you change them to an x, so then you can put them in the calculator. Okay? Let's look at number 5. I want you to take a minute, and I want you to try and do this one. Okay, so right here on this one, the biggest thing is you look in between the parentheses. There's a plus sign. Okay, so that means I don't have to worry about changing the sign of anything. I just have to find the things that go together. This first term is an a squared. Anywhere in there, is there another a squared? In the rest of this? No, there's not. So that one just stays alone. 3a squared. Nothing we need to do with that. Now, the next term I have is a 3ab. Do we have another ab? We sure do. And that's a positive 4ab. Well, what's 3 plus 4? 7. So plus 7ab. The last one that I see in here is a negative b squared. Do we have a b squared anywhere? Yeah, we got positive 6b squared. Well, this is the same as negative 1. What's negative 1 plus 6? Positive 5b squared. And this would be our answer. Now, again, because it says AB, it has more than one letter in it, we can't even change the letters to be able to check it in the calculator. The difference will be that on the lessons that I have on here that I've done in the past, it's very much straight, just the x and the y's and the x squareds and the x's. So it may be easier for some people. Number 6. What do you notice that's in between the two parentheses? The minus. So what I like to do is this. I will rewrite the first thing, what's in the first parentheses, because I don't do anything to it. Now, the second one right here, this is like a negative 1. So negative 1 times 2y, negative 2y, negative 1 times negative 4y. A negative times a negative is a positive 4y. Negative 1 times 3, negative 3. Take a minute and simplify. Put together the terms that go together. Oh, I forgot a squared on one of them, didn't I? There we go. How many y squareds do I have? I have 5 minus 2, which is 3y squared. My y's, I have a 7y plus a 4y. So plus 11y. And then I have 8 minus 3 plus 5. Okay. Now, I want you to take a minute and I want you to try and think what we would have to do in order to answer this question. First off, I need you guys to remember, what does perimeter mean? Add up all the sides. Okay? So I want you to take a minute and I want you to try and figure out, first off, I want you to try and figure out what you would do to solve this problem. I'm going to give you just a couple minutes. All right, so I'm not going to do the problem yet, but I want to know, what do I need to do first? What would be my plan of attack here? Okay, so add the two sides that they give us right here, right? So this one and this one, we need to add these together. So I am going to do that part. I've got 1x squared and 2x squared. So I'm going to have 3x squared, and then we have 3x and 3x, which gives me 6x, and then 6 minus 5, which is 1. Okay, so that's the first part. So now what do we do? Subtract from what the perimeter is? Okay, but how are we going to write that? Now, some of you may be like, I'm not going to write it. I'm just going to subtract it. Okay, but I'm going to slow down just a minute. But what I mean is, if I had to rewrite it out, okay, so I'm going to take the 4x squared, right, plus 5x plus 5, and I'm going to subtract my 3x squared plus 6x plus 1, right? Now, some of you guys are going to totally see, and I get this, you're going to see that all I have to do is subtract 4 minus 3, right? And 5 minus 6, and 5 minus 1, and that's okay. I'm just writing out the steps. Some of you I totally just lost with what I just said. I'm going to try and find you all. All right. So what we're doing here is the first part stays the same. The 4x squared plus 5x plus 5. So I have to subtract off minus 3x squared minus 6x minus 1. Well, to find my answer, 4 minus 3, 4x squared minus 3x squared, 1x squared, 5x minus 6x, negative 1x, and 5 minus 1 is 4. This would be my missing side. X squared minus x plus 4. Now, yes, ma'am. You said you did it a different way. What did you do? Yeah, what you're saying is you looked at these two right here and got 3x squared in your mind. You got 3x squared and you're saying, well, what's missing to put right here? And that's an x squared. And that's fine too. That's exactly. I mean, like I said, there's many different ways to find this answer. What if I wanted to check and make sure I was right? After I think this is what my answer, what would be the logical thing to do? To go back and like kind of, Kimberly, the other way that you went, instead of trying to figure out the missing side now. Once you find all the sides, can't you just go x squared and x squared? That's 2, 4x squared. Add them up like we're doing perimeter. And go 3 plus 3 is 6. Minus 1 is 5. And then we have 6 plus 4 is 10. 10 minus 5 is 5. Right? We could go back and add them back up to make sure that we didn't make a mistake and that we got it right. But you're right. Probably in my own head, if this was my problem, I wouldn't have gone through and written it out in detail like this. It's just the way that we were teaching the lesson. I would have done what you did. I would have looked to see what am I missing in my x squares right here to put it there. Okay, and nothing is wrong with that. All right. Let's see. Oh, I thought I was done. I lied. Turn the paper over. Ha ha. Some of you guys were like, dang, I didn't know there was a back. Neither did I. Okay, this one says, find the area of the shaded region, and it gives you the, if that whole 9x squared minus 6xy plus 3y squared is the area of the total region, and 3x squared plus y squared is the area of the unshaded. Whoa. Okay. So this is the big rectangle. This piece right here is the unshaded down here. How do I find the area of this shaded area? I would subtract. So you can do it a couple different ways. Take a minute and try and solve this one. So on this one, all we're going to do is we're going to take the area of the total region, which is 9x squared minus 6xy plus 3y. And you're going to subtract off the area of that unshaded region. And I'll line them up because it's 3x squared, so 3x squared and, oh, I forgot that squared right there. Plus y squared. I'm going to line mine up this way. Well, I know that I've got to subtract off this one and subtract off this one. So I have 9 minus 3, which is 6x squared. There was no other xy, so it still becomes minus 6xy. Then right here I have 3 minus 1, which is plus 2y squared. This is what you should have gotten for the area of the shaded region. Number 9. It said find the total area of the figure. So we're going to go and look. Let's see, to find the total area, I have to add up the things that are all the same. Well, first off, I see a 13x squared. Do I see any other x squareds? No. So it's 13x squared. The next term that I see is xy. There's no other xy's. So I put plus xy. The last one is y squared. Well, I have 1y squared, 2, 3, 4, 5y squared. So my answer would be 5y squared, and that's all you would do to find the total area of the figure. Number 10, find the area of the shaded region if the area of the total region is 5x squared minus 4xy plus 2. So all you're going to do is take the total area, 5xy minus 5x squared minus 4xy plus 2, and I'm going to subtract off the x squared and the xy. Well, so this is going to be a minus, and this is going to be a minus, okay, because I'm subtracting them off. So my answer becomes 4x squared. You subtract these right here, minus 5xy plus 2. We didn't have anything to do with the units. This is the area of the shaded region. All you did was take the original, the area of the total region, and subtracted off these pieces.